changing use of paper. We are using paper not only for writing and printing, but we are basically using it for different applications. Where to use it for different application, we have to modify it systematically. So few modifications only use certain polymers which were earlier mostly synthetic or petroleum based, which we are trying to replace them with the biopolymers, and the biopolymer may also act as the antimicrobial effect or the pro-microbial effect. Now, not only the biopolymer, but to enhance different barrier properties and different strength properties, we are also using the nanomaterials. So basically in this study we have used the nanocellulose, and we have taken two biopolymers. One is the pro-microbial. It means that it will enhance the biodegradability rate, and one is the antimicrobial that will delay or retard the biodegradation rate. This is basically what the outline of the presentation is, why we want to do this research, what is the research gap, and how we have performed the overall conclusion, what is the studies lacking, what are the limitations which we will do it in future. Now, the need of study is, one is what I have written, that currently paper is the only solution for sustainable packaging, but when we make paper to be very effective as a packaging material, we have to modify it either at wet end or at surface sizing. Now when we modify paper for the gutka packaging, that is suitable for gutka packaging, then see, the people will eat and throw. So there is no concept of recovery. There is the only one concept of biodegradability. If that package is biodegradability, if that package can degrade in the soil, it is good for us, for the environment and for the Mother Earth. If it is not going to do that, it is going to do as it is with the plastic material, then there is no use of saying that it is having 80% of paper and rest is polymer. That is a bigger research gap. Now what we have done, basically this is a slide which is showing that how many types of biopolymers are there. Polyester based biopolymers, polysaccharide based biopolymers, and we can say is protein based biopolymers. From these you can, there are many biopolymers that can be used for the surface modification. They will give different barrier properties and enhance the strength properties as well as of the paper after surfacizing. Now what we have done is we have taken virgin wood pulp. I am again saying it is a social forestry virgin wood pulp, not from the forest. The other is the OCC, which is the larger chunk of the recycled fiber. Because we are basically on the packaging approach, so I have not taken any writing, printing, recycled or anything. Then we have made the base sheets. Now we have two papers. One is made from the wood pulp and one is made from the recycled pulp. The first thing is there any difference in the biodegradability rate of these two pulps? So how we have done it? See the basic method to do biodegradability test, which I have given in future limitations in last few slides, in last one slide. We have taken the approach of soil burial method. This is taken from EN 14045 2013. In this we will make the paper and we will bury it in the soil, and accordingly at some specific intervals of a week we will check the biodegradability. Now you might think that both will degrade at the same pace, but the results are that OCC pulp degrade faster than the wood-based pulp. So now a paper made of OCC or a paper made of only wood-based pulp is not going to have any packaging application or a larger packaging application. So we have to modify this. So for modification approach, we have used biopolymer. One is pro and one is antimicrobial. We have made a solution of 2%. And the surface sizing of the paper which we have made earlier in the slide, we have surface sized it by the laboratory's pond size press, and the sizing pickup weight was 45 plus minus 5 kg per ton. I have taken it on a higher side so that I can have a larger effect of it. Because in mills they might be doing 20-25 kg or less, but I have taken the higher amount so that I can see the impact clearly. Now after that the sheets were tested for biodegradability test. Now what are the impact of pro and anti? See, pro microbial will enhance the microbial activity, because so the time to biodegrade the paper will reduce after the pro microbial, and after antimicrobial it will increase. Now what are the results? Now this is the another approach, and results are after these slides. Now in this approach, I have used biopolymer. Again, it was prepared of 2%, and 5% nanocellulose was blended in it. For proper mixing, we have used microfluidizer, where we have given a pressure of 300 psi, so that it can mix well, and the flow for surface sizing in the pond size press is good. The size pickup here also was taken 45 plus minus 5 kg, so that we can have a good comparison. Now nanomaterials fills the pores, and it makes the paper almost non-porous. So therefore there is an increase in the biodegradability rate. Now what are the results? The biodegradability of pro-microbial paper coated plus pro-microbial nano-coated. What we see that pro-microbial degrades the paper, OCC base degrades in 4 weeks, but when we use nanomaterial, the degradation now takes 100 days. Similarly, in case of wood-based, the paper with pro-microbial coated degrades in 6 weeks, but with the nano-coating, which is the nanocellulose, the biodegradability rate goes to 100 days. Now similarly, this chart shows that with the use of nanomaterial along with the pro-microbial biopolymer, there is an increase in the tendency of paper to degrade, so it will delay. The biodegradability rate will delay when we will use nanomaterials in case of pro-microbial. Now in case of antimicrobial, the OCC pulp, we know that it will take, after antimicrobial, it will take 12 weeks. Initially it was taking 4 weeks. And then when we mix the nanomaterial with the antimicrobial, again it will degrade in 16 weeks. The other case of wood also shows the same trend. So here also with antimicrobial biopolymer coating on paper, the degradation rate will slow down, and with the use of nanomaterial it will further slow down. Now what is the limitation of work? To have an exact idea of what is happening after every week when we take out the paper, we should have done the SEM analysis. But because this was a study done in the initial phase, and we were not thinking of that we will get different results in the biodegradation in respect to time. So next study we will definitely see the SEM impact, so that we can have the idea that how the paper fiber is degrading. The second thing is, the biodegradability test should be done as per how when paper degrades or any material degrades, so it gives out the CO2. So the CO2 measurement should be done. In our case, what we have done, we have just compared the papers. So in our case, there is the biological degradation as well as the physical integration. But if the same study would be done as per the CO2 release method, then it will be more appropriate. Now, the dark green color shows the faster degradation, and the red color shows the slower degradation. Here also, this is the overall conclusion that the pro-microbial OCC paper, coated paper, will degrade most in less time, and the antimicrobial coated paper will take more time to degrade. Now, what are the conclusions? The first conclusion is the fiber furnish significantly impacts the biodegradation. The OCC fiber degrades much faster than the wood-based pulp. Pro-microbial biopolymer, if you will use in surface sizing, it will reduce the time of degradation. If you will use antimicrobial biopolymer in surface sizing, it is going to increase the time of degradation of paper. When you will add nanomaterial, either with pro-microbial or antimicrobial, there will be increase in the biodegradation time of the paper. So, what is the final outcome? Appropriate combination of fiber furnish, biopolymer type, and nanomaterial enables tailored biodegradable sustainable packaging. So, to have a sustainable packaging, we have to take care of all these 3 points. That what is the raw material we are using, what is the biopolymer we are taking, and how the nanomaterial, how much the quantity of nanomaterial is there. If the paper is going to become non-porous by all these modifications, then 100% the time of biodegradation will be higher. Thank you for patient listening.